Σας καλωσορίζουμε στο βιβλιοπωλείο των Πανεπιστημιακών Εκδόσεων Κρήτης για την παρουσίαση του νέου βιβλίου του Νταβίντ Ελμπάζ, 10.001 νύχτες του σύμπαντος, σε μια πολύ σημαντική μέρα για την επιστήμη και την ανθρωπότητα, καθώς πραγματοποιήθηκε σήμερα η εκτόξευση της αποστολής Άρτεμις 2, για το οποίο θα μας μιλήσει και ο ίδιος ο συγγραφέας. Χαιρόμαστε λοιπόν που σε μια τόσο σημαντική ημέρα φιλοξενούμε τον Νταβίντ Ελμπάζ, ένας από τους αγαπημένους μας συγγραφείς, όπου κατά τη γνώμη μας είναι ένας σύγχρονος παραμυθάς του σύμπαντος και έχει τη μοναδική ικανότητα να μετατρέπει την επιστήμη σε ιστορία, τη γνώση σε φαντασία και το σύμπαν σε μια συναρπαστική αφήγηση για όλους μας. Ο Βασίλης Χαρμανδάρης, καθηγητής φυσικής του Πανεπιστημίου Κρήτης και ο επιστημονικός επιμελητής όλων των βιβλίων του David Elbaz, δεν μπόρεσε να είναι σήμερα μαζί μας. Παρ' όλα αυτά, έχει γράψει 2 γραμμές που θα ήθελα να μοιραστεί μαζί σας. Όπως γράφει ο ίδιος, ο David Elbaz με το νέο του βιβλίο «Οι 10.001 νύχτες του σύμπαντος, ο χορός του κόσμου», ολοκληρώνει μια πρωτότυπη τριλογία, παρουσιάζοντας με ένα μοναδικό τρόπο όχι απλά τις γνώσεις που έχουμε για τον κόσμο που μας περιβάλλει, αλλά και ποια ήταν τα ερωτήματα που μας προβλημάτιζαν και πώς προοδευτικά οδηγηθήκαμε στις απαντήσεις του. Με το νέο του βιβλίο, ο συγγραφέας εξηγεί με απλά λόγια και σαφήνεια πώς η βαρύτητα και η κίνηση καθορίζουν τη δημιουργία όλων των δομών, από τη μορφή των γαλαξιών μέχρι το σχηματισμό νέων πλανητών που ανακαλύπτουμε γύρω άλλα αστέρια. Παράλληλα, ο Ελμπάζ μας θυμίζει το πώς τα εργαλεία κάνουν το μάστορα. Έτσι και για εμάς τους αστρονόμους, από το Γαλιλαίο πριν από 400 χρόνια μέχρι και σήμερα, τα τηλεσκόπια είναι αυτά που μας προσφέρουν την απαραίτητη πληροφορία, την οποία καλούμαστε να ερμηνεύσουμε. Σαν μια νέα Σεχραζάτ, όπως λέει και στο πιστόφυλλο του βιβλίου του, που κρατούσε αμύωτο το ενδιαφέρον του Σουλτάνου Σαχριάρ για 1001 νύχτες, η ιδιαίτερη πένα του Νταβίντ Ελμπάζ θα οδηγήσει όλους τους αναγνώστες αυτού του νέου βιβλίου να το διαβάσουν από την αρχή μέχρι το τέλος μέσα σε μία και μόνο νύχτα. Μαζί μας λοιπόν σήμερα έχουμε την Αναστασία-Φιόρη Μεταλληνού από το Εθνικό Αστεροσκοπείο Αθηνών. Είναι υπεύθυνη επικοινωνίας των κέντρων επισκεπτών. Επίσης συμμετέχει στο Διεθνή Αστρονομική Ένωση πάλι σε θέματα επικοινωνίας και έχουμε τη χαρά σήμερα να συντροφεύει την παρέα μας και να ξεκινήσει τη σημερινή βραδιά συνδέοντας κάτι κοινό που έχουν οι δυο τους, την αγάπη τους για την τέχνη και την επιστήμη. Επομένως θα δώσουμε το λόγο στην κυρία Μεταλληνού, η οποία θα μας ταξιδέψει λίγο σε αυτό το πεδίο και στη συνέχεια θα ακολουθήσουμε με τον κύριο David Elbaz. Ευχαριστώ πολύ.
Ευχαριστώ πολύ την αγαπητή συνεργάτηδα και πρώην συνάδελφο στο Αστεροσκοπείο, την Ελένη τη Χριστιά, της Πανεπιστημιακές Εκδόσεις Κρήτης. Και είναι μεγάλη χαρά μας που ο κύριος Ελμπάζ είναι μαζί μας απόψε για άλλη μια φορά στην Αθήνα, παρουσιάζοντας ένα ακόμα βιβλίο του. Θα ξεκινήσω με 2 λόγια για τον απόψινό μας τιμόμενο αστρονόμο, τον κύριο Ελμπάζ, ο οποίος είναι Γάλλος αστροφυσικός, ειδικός στο σχηματισμό και την εξέλιξη των γαλαξιών. Είναι διευθυντής ερευνών στο τμήμα Αστροφυσικής της Επιτροπής Ατοµικής Ενέργειας και Εναλλακτικών Μορφών Ενέργειας στη Γαλλία και επιστημονικός υπεύθυνος του Ευρωπαϊκού Οργανισμού Διαστήματος. Ασχολείται ενεργά με την εκλαΐκευση της επιστήμης, πράγμα το οποίο αποδεικνύεται και με το συγγραφικό του έργο και με τις παρουσιάσεις, τις ομιλίες του, τις performances που πραγματοποιεί ανά τον κόσμο. Για το επιστημονικό του έργο έχει βραβευθεί από την Αμερικανική Αστρονομική Εταιρεία και το Ινστιτούτο της Γαλλίας. Εκτός από τις πολλές επιστημονικές εργασίες που έχει δημοσιεύσει, έχει γράψει και 2 επιστημονικά μυθιστορήματα. Με τις Πανεπιστημιακές Εκδόσεις Κρήτης κυκλοφόρησε στα ελληνικά το βιβλίο του «Αναζητώντας το αόρατο σύμπαν» το 2021 και το 2024 το «Πιο όμορφο τέχνασμα του φωτός». Απόψε θα εστιαστούμε στο 10.001 νύχτες του σύμπαντος με υπότιτλο «Ο χορός του κόσμου». Οπότε με αφορμή το χορό του κόσμου που αναφέρει ο κύριος Ελμπάζ, συγκέντρωσα κάποια στοιχεία, μου έδωσε αφορμή για πολλά στοιχεία, αλλά θα με μαλώσουν αν επεκταθώ εδώ οι οργανωτές. Οπότε θα αναφερθώ και στο χορό, ο οποίος χορός για να υλοποιηθεί απαιτεί ρυθμό, απαιτεί μουσική. Οπότε θα σας μιλήσω για τη μουσική του σύμπαντος, τη μουσική του κόσμου, πώς συνδέεται με το χορό. Οπότε ποια είναι η σύνδεση της αστρονομίας με τις μούσες ουσιαστικά. Οπότε 2 κουβέντες για το πώς η αστρονομία συνομιλεί με τις μούσες. Σε αυτό το έργο που είναι του Σιμών Βουέ, ένας Γάλλος ζωγράφος 17ου αιώνα, απεικονίζει δύο μούσες με τους ερωτηδείς να πετάνε γύρω από αυτές. Είναι η μούσα Ουρανία, η μούσα της αστρονομίας και δίπλα της η Καλλιόπη, η μούσα της επικής ποίησης. Στην αρχαιότητα, στην ελληνική μυθολογία, η Ουρανία, η αστρονομία συγκαταλέγεται μεταξύ των μουσών. Οπότε συνομιλεί εκ των πραγμάτων με όλες τις μούσες, της ποίησης, του χορού, της μουσικής, του θεάτρου. Οπότε στη συνείδηση των αρχαίων Ελλήνων η αστρονομία ανήκει στις μούσες και είναι μία από αυτές, εμπνέει και τις υπόλοιπες. Η θεώρηση του κόσμου από την Πυθαγόρια σκέψη και η θεωρία της μουσικής των σφαιρών ή της αρμονίας των σφαιρών είναι ουσιαστικά μια θεωρία που έχει τις αναφορές της ήδη από τον 6ο αιώνα π.Χ., όπου Πυθαγόροι, αστρονόμοι, φιλόσοφοι, μουσικοί, θεωρητικοί της μουσικής, ουσιαστικά θέλουν να περιγράψουν το σύμπαν, τον κόσμο, μέσω των αρμονικών σχέσεων που οι αριθμοί ορίζουν. Γιατί, καθώς κατά το κοσμολογικό μοντέλο των Πυθαγορίων οι πλανήτες κινούνται γύρω από το κεντρικό πυρ, η κίνηση αυτή είναι μια περιοδική κίνηση και η περιοδικότητα είναι μια συχνότητα και η συχνότητα είναι ένας ήχος, είναι μια μουσική νότα, είναι ένα μουσικό διάστημα. Οπότε φαντάζονται και θέλουν να ερμηνεύσουν τον κόσμο με όρους της μουσικής, η οποία μουσική περιγράφεται από τα μαθηματικά. Και η αρμονία των σφαιρών ουσιαστικά είναι μια θεώρηση του κόσμου που συνδέει την αστρονομία και τη μουσική μέσω των μαθηματικών και της αρμονικής σχέσης των μαθηματικών. Οπότε το λεγόμενο μονόχορδο του Πυθαγόρα διαιρεί μια χορδή σε τμήματα και ανάλογα με το τμήμα που χωρίζουμε τη χορδή, δημιουργούνται διάφορα διαστήματα, διάφορες μουσικές νότες, όπως ξέρουμε η μουσική σήμερα. Οπότε ο λόγος των ακεραίων αριθμών που ορίζουν αυτά τα κλάσματα καθορίζει και την αρμονική σχέση μεταξύ των παραγόμενων διαστημάτων. Και ο Πυθαγόρας, η σχολή του Πυθαγόρου ουσιαστικά, εκτελεί πειράματα με το μονόχορδο, με αυλούς, με κρουστά και μαθηματικοποιεί τη μουσική, χρησιμοποιεί τα μαθηματικά και βγάζει το συμπέρασμα ότι ο αριθμός είναι αυτός που καθορίζει την αρμονία και τις αρμονικές σχέσεις μέσα στη μουσική. Βέβαια, ο Αρχίτας, Μέγας Πυθαγόριος, θεωρεί ότι το πρόβλημα της αρμονίας, η θεώρηση της αρμονίας των σφαιρών είναι ένα φυσικό ζήτημα, διότι η κίνηση των πλανητών, η κίνηση των ουρανίων σωμάτων σε τροχές, είναι μια περιοδικότητα και αυτή η περιοδικότητα είναι μια συχνότητα, όπως λέγαμε και πριν, και προσεγγίζει το θέμα ως φυσικός, μελετώντας αυτές τις περιοδικές κινήσεις. Με την αρμονία των σφαιρών, αυτή η θεωρία μέχρι σήμερα έχει επηρεάσει και την αστρονομία και την επιστήμη και τις τέχνες. Όλες τις τέχνες, κυρίως τη μουσική. Ο Κέπλερ, μεγάλος αστρονόμος, το 16ο αιώνα εκδίδει το βιβλίο περί της αρμονίας του κόσμου και προσπαθεί ουσιαστικά να δει αν αυτά τα διαστήματα τα οποία περιγράφουν την αρμονία της μουσικής και τα οποία ψάχνουν οι Πυθαγόριοι στον ουρανό. Οπότε ο Κέπλερ ασχολείται με την αρμονία των σφαιρών, την αρμονία του κόσμου. Και ουσιαστικά αυτό που κάνει ο Κέπλερ είναι ότι υπολογίζει, μετράει την ταχύτητα περιστροφής των πλανητών όταν είναι πιο κοντά. Οπότε ο Κέπλερ ασχολείται με την αρμονία των σφαιρών, μελετώντας ουσιαστικά, υπολογίζοντας την ταχύτητα περιστροφής των πλανητών γύρω από τον ήλιο και παρατηρεί ότι στο περιήλιο, πιο κοντά στον ήλιο, κινείται με μεγαλύτερη ταχύτητα ένας πλανήτης από ότι στο αφήλιο, στην πιο μακρινή απόσταση, που είναι πιο αργή η κίνηση. Διαιρεί αυτές τις ταχύτητες και συγκρίνει τους λόγους που δημιουργούνται στους διάφορους πλανήτες και φτάνει κάπως κοντά στα διαστήματα με τα οποία χρησιμοποιούν οι Πυθαγόροι για τη διαίρεση των χορδών. Μέγας Πυθαγόριος και ο Κέπλερ, στην αναζήτηση λοιπόν της αρμονίας των σφαιρών, καταλήγει και διατυπώνει τους νόμους του Κέπλερ που γνωρίζουμε σήμερα και οι οποίοι περιγράφουν τις κινήσεις των πλανητών γύρω από τον ήλιο μας. Αυτή η θεωρία επηρεάζει και την ποίηση. Και εδώ παίρνει κάποιοι στίχοι από τον ποιητή τον Μίλτονα, τον Άγγλο ποιητή του 17ου αιώνα, ο οποίος όπως διαβάζετε, γράφει. Αλλά στην καρδιά της νύχτας, όταν ο ύπνος πέφτει στα χωράφια των θνητών, τότε ακούω την αρμονία των ουράνιων σιρήνων. Μια δύναμη τόσο γλυκιά κατοικεί τη μουσική, αυτή να νουρίζει τις κόρες της ανάγκης και διατηρεί τη μετέωρη φύση στην ομοτέλειά της. Και θέτει τον κανόνα στον κάτω αυτό κόσμο, στο ρυθμό ουράνιων ήχων, που κανένας δεν ακούει ανάμεσα στους ευτελείς ανθρώπους με τη μυαρή ακοή. Οπότε οι αναφορές στις σιρήνες που κατά τον Πλάτωνα ήταν δίπλα από την ανάγκη, η οποία ανάγκη κρατάει ένα σφόνδυλο, όπως περιγράφει στην Πολιτεία ο Πλάτωνας, όπου η ανάγκη που εκπροσωπεί το φυσικό νόμο έχει ομόκεντρες σφαίρες στην αγκαλιά της, σε κάθε σφαίρα βρίσκεται ένας πλανήτης και μια σιρήνα, και η σιρήνα παράγει ήχο. Και ο ήχος που παράγεται από την κάθε σιρήνα στην κάθε σφαίρα καθενός από τους πλανήτες, όταν συνεχούν αυτοί οι ήχοι, το αποτέλεσμα είναι αρμονικό και περιγράφει με αυτόν τον ποιητικό τρόπο την αρμονία των σφαιρών. Σήμερα, η αρμονία των σφαιρών μπορεί να παραλληλιστεί με τις προσπάθειες, με την εργασία που κάνουν και αστρονόμοι και τεχνικοί ήχου και συνθέτες και άνθρωποι που ασχολούνται με τον ήχο σε θέματα ηχοποίησης, sonification στα αγγλικά, ηχοποίηση αστρονομικών δεδομένων, που μια παράμετρος μπορεί να μεταφερθεί σε ήχο, ούτως ώστε ένα αστρονομικό φαινόμενο να περιγραφτεί και ακουστικά. Οι αστρονόμοι έχουμε συνηθίσει και παρατηρούμε τα φαινόμενα, καταγράφουμε τις μετρήσεις μας και μέσα από τα διαγράμματα, οπτικά, μπορούμε να ερμηνεύσουμε την εξέλιξη ενός φαινομένου και να δούμε στο χρόνο πώς εξελίσσεται μια θερμοκρασία, η πίεση, το μαγνητικό πεδίο. Αν λοιπόν αυτές τις παραμέτρους τις μετατρέψουμε σε ήχο και αντιστοίχηση, η μετατροπή είναι σωστή, τότε περιγράφουμε και ακουστικά πολλά φαινόμενα της φυσικής και της αστρονομίας. Ένα παράδειγμα είναι εδώ από μια ηχοποίηση που έχει γίνει με το τμήμα ήχου και εικόνας στο Ιόνιο Πανεπιστήμιο, αλλά είναι ηχοποίηση διαταραχών του μαγνητικού πεδίου της Γης, καθώς επηρεάζεται από τον ήλιο και τον ηλιακό άνεμο, και αυτά είναι δεδομένα που έχουν χρησιμοποιηθεί από μαγνητόμετρα του δικτύου μαγνητομέτρων του Εθνικού Αστεροσκοπείου Αθηνών, σε συνεργασία με συνεργάτες στο Ιόνιο Πανεπιστήμιο. Οπότε αυτό που ακούμε ουσιαστικά είναι η διαταραχή του μαγνητικού πεδίου της Γης σε περιόδους έντονης μαγνητικής δραστηριότητας, η οποία επηρεάζεται πάρα πολύ από τον ήλιο μας. Άλλη μια περίπτωση ηχοποίησης δεδομένων μαγνητικών καταιγίδων είναι αυτή που έχει γίνει σε συνεργασία με το Πανεπιστήμιο Αθηνών και παρουσιάστηκε και ως εργασία σε ένα σπουδαίο συνέδριο, το COSPAR, όταν έγινε στην Αθήνα. Και αυτοί είναι ήχοι που παράγονται, διαταραχές του μαγνητικού πεδίου, που μετατρέπονται σε ήχο κατά τη διάρκεια μιας μαγνητικής καταιγίδας. Υπάρχουν αρκετές εφαρμογές που έχουμε κάνει με συνεργάτες και τις οποίες τις χρησιμοποιούμε, μπορούν να χρησιμοποιούν και για επιστημονικούς λόγους, διότι ο ήχος έχει κάποιες λεπτομέρειες και περιγράφει φαινόμενα που ίσως η όρασή μας δεν τα πιάνει κατευθείαν, αλλά ο ήχος έχει κάποια πλεονεκτήματα, αλλά χρησιμοποιείται και για άλλους λόγους. Θα δούμε στη συνέχεια. Μπορούμε να ηχοποιήσουμε και την περιστροφή των ταχύτατα περιστρεφωμένων αστέρων νετρονίων, που είναι τα pulsars, που καθώς περιστρέφονται γύρω από τον άξονά τους, οι δέσμοι ακτινοβολίας που εκπέμπουν από τους δύο πόλους, πολύ ισχυρή ακτινοβολία και στα ραδιοκύματα, δημιουργεί αυτή την εκπομπή που όταν τη συλλαμβάνει ένα ραδιοτηλεσκόπιο, παίρνουμε ένα σήμα και έτσι ανακαλύφθηκαν και τα pulsars τη δεκαετία του 70 από τη Jocelyn Bell. Οπότε εδώ είναι μια εφαρμογή που σε αυτό το σμήνο αστέρων του Κάνα, στο νότιο ημισφαίριο, έχουμε επιλέξει τα pulsars, ο Μίχαλ Κράμερ το έχει κάνει, ραδιοαστρονόμος από τη Βόνη, την περιστροφή τη μετατρέπει σε ήχο και όταν συνηχούν όλα τα pulsar που υπάρχουν σε αυτό το σμήνος, το αποτέλεσμα είναι αυτό που ακούμε τώρα. Ένα άκουσμα σαν σύγχρονη μουσική, σαν ηλεκτρονική μουσική. Είναι διαστήματα που είναι σύμφωνα ή που είναι διάφωνα και μετά λύνονται και γίνονται σύμφωνα, έτσι άμα το αναλύσουμε με λίγο όρους μουσικούς. Οπότε, εφαρμογές που έχουν γίνει στην ηχοποίηση αστρονομικών δεδομένων αφορούν την συγχώνευση μελανών οπών, την περιστροφή αστέρων νετρονίων, εκρήξεις υπερκενοφανών έχουν ηχοποιηθεί. Μεταβλητοί αστέρες, η λαμπρότητα των μεταβλητών αστέρων μπορεί να δημιουργήσει, να ηχοποιήσει των φαινομένων αυτών. Φάσματα γαλαξιών έχουν μεταφερθεί στο ακουστικό εύρος συχνοτήτων για να τα ακούμε. Ηλιακά φαινόμενα, μαγνητικές καταιγίδες που σας είπα πριν, ακόμα και διαβάσεις εξωπλανητών μπορούν να περιγραφούν μέσω του ήχου. Λοιπόν, ο William Herschel ήταν ένας πολύ σπουδαίος αστρονόμος του 18ου αιώνα. Αστρονόμο, τον ξέρουν οι αστρονόμοι, στη θεωρία της μουσικής, στην ιστορία της μουσικής, το 2, διαβάζαμε για τον Herschel ότι ήταν ένας σπουδαίος συνθέτης της αναγέννησης. Εγώ πριν λίγα χρόνια κατάλαβα ότι αυτά τα δύο πρόσωπα είναι ένα, δεν ήταν δύο διαφορετικά πρόσωπα. Ο Herschel, λοιπόν, ξεκινώντας την καριέρα του ως συνθέτης κλασικής μουσικής, με συμφωνίες, κοντσέρτι που έχει γράψει να παίζονται μέχρι σήμερα στο διεθνές ρεπερτόριο, υπήρξε αρχικά ερασιτέχνης αστρονόμος που σιγά σιγά άφησε τη μουσική σε κάποια στιγμή γιατί ασχολήθηκε με την αστρονομία. Και όχι απλά ασχολήθηκε, στην εποχή του είχε κατασκευάσει το μεγαλύτερο τηλεσκόπιο που είχε φτιαχτεί στην Αγγλία. Ανακάλυψε τον πλανήτη Ουρανό. 2 δορυφόρους του χρόνου, 2 του ουρανού, είδε ότι ο ήλιος κινείται γύρω από το κέντρο του γαλαξία, ανακάλυψε πολλούς διπλούς και τριπλούς αστέρες και συνέταξε ένα κατάλογο με 2.500 νεφελώματα, τα έλεγε. Περιοχές στον ουρανό που έμοιαζαν με νεφέλωμα, σήμερα ξέρουμε ότι είναι γαλαξίες, άλλοι γαλαξίες πέρα από το δικό μας. Πολύ σπουδαίο ερευνητικό έργο, ανακαλύπτει την υπέρυθρη ακτινοβολία, ασχολείται με τα φάσματα των αστέρων. Είχε και μια αδελφή, μια από τις αδελφές του, η Καρολίνα Herschel, η οποία ήταν και αυτή σπουδαία αστρονόμος και μάλιστα υπήρξε η πρώτη γυναίκα που αμείφθηκε με μισθό από το αγγλικό κράτος τότε, η πρώτη γυναίκα αστρονόμος που πήρε μισθό για την επιστημονική της εργασία. Ήταν βοηθός του και συνεργάτης του αδελφού του Herschel. Λοιπόν, όταν ο Ιώσεφ Χάιντεν, επισκέπτεται το Herschel στο Λονδίνο το 1782 και παρατηρεί μέσα από το τηλεσκόπιό του, φαντάζομαι, εμπνέεται από τη συνάντηση και συνθέτει τη δημιουργία. Ένα γνωστό έργο του Χάιντεν, το οποίο μέρος το φως ξεπροβάλλει, περιγράφει, ακούγοντάς το, ουσιαστικά τη δημιουργία του κόσμου. Με μια εξέλιξη στη μουσική που φτάνει σε ένα αποκορύφωμα, με μεγάλες εντάξεις, με πολύ φόρτε και φαίνεται ότι είναι επηρεασμένος, έχει επηρεαστεί από τη συνάντησή του με το Herschel. Ο Byron, ο Λόρδος Byron, συναντά επίσης το Herschel και παρατηρεί με το τηλεσκόπιό του. Και μετά την παρατήρηση γράφει στο ημερολόγιό του ότι, το γράφω στα αγγλικά εδώ, η νύχτα είναι τόσο ένα θρησκευτικό ζήτημα και ακόμα περισσότερο, γιατί είδα μέσα από το τηλεσκόπιο τη σελήνη και είδα μέσα από το τηλεσκόπιο ότι υπάρχουν και άλλοι κόσμοι. Οπότε περιγράφει τα αντικείμενα που είδα από το τηλεσκόπιο του Herschel σαν άλλους κόσμους, με την ευρύτερη έννοια του κόσμου. Και γράφει σε ένα ποίημά του, στο Δον Χουάν, τα εξής, ο Μπάιρον. Για εκείνους που με τη βοήθεια του γυαλιού και του ατμού, γυαλί εννοεί το τηλεσκόπιο, και εκείνοι που με τη βοήθεια του γυαλιού και του ατμού ανακαλύπτουν αστέρια, είναι οι αστρονόμοι, και ταξιδεύουν στο μάτι του ανέμου, θα ήθελα να κάνω τόσα κι εγώ με την ποίηση. Στο μάτι του ανέμου κι αν έχω ταξιδέψει. Αλλά για τα αστέρια κατέχω τηλεσκόπιο που είναι θολό. Αλλά τουλάχιστον άφησα την κοινή ακτή και άφησα τη στεριά που μάτι δεν τη βλέπει πια, μακριά ο ωκεανός της αιωνιότητας, ο βρυχυθμός. Εμπνέεται λοιπόν από το φίλο του τον αστρονόμο και γράφει αυτούς τους στίχους. Και σε κάποιο άλλο σημείο, στο έργο του Κάιν, γράφει ο Μπάιρον. Και αν σου έλεγα πως υπήρξαν κόσμοι ανώτεροι από το δικό σου, κατοικημένοι από όντα σπουδαιότερα από σένα και πολύ μεγαλύτερα σε αριθμό από όσους κόκκους χώμα έχει η μουντή σου γη, πολλαπλασιασμένα σε γεμάτα ζωή άτομα, όλα ζωντανά και όλα καταδικασμένα σε θάνατο, τι θα σκεφτόσουν. Οπότε μας κάνει μια αναφορά για κόσμους άπειρους, πολύ μεγάλους αριθμούς κόσμου, που μπορεί να έχουν και όντα, μπορεί και να μην έχουν. Οπότε συνειρμικά η σκέψη μας πάει σε έναν φιλόσοφο, τον Επίκουρο, της ελληνιστικής περίοδου, ο οποίος επηρεασμένος από το Δημόκριτο και το Λεύκηπο και την ατομική τους θεωρία, μιλάει ο Επίκουρος για άλλους κόσμους. Και κόσμους αναφέρει που μπορεί να είναι παρόμοιοι και μπορεί και να μην είναι παρόμοιοι με το δικό μας. Και όταν ο Επίκουρος λέει κόσμος, ο ορισμός που δίνει, λέει ότι κόσμος είναι κάποια περιοχή του ουρανού που περικλείεται από όρια, που περιέχει άστρα και γη και όλα τα φαινόμενα που ορίζουν αυτόν τον κόσμο. Οπότε με τη σύγχρονη ματιά, ένας κόσμος μπορεί να είναι ένα πλανητικό σύστημα, να είναι ένας μήνος αστέρων, μπορεί να είναι ένας από τους γαλαξίες που μελετάει ο κύριος Ελμπάζ. Αυτή είναι η αντίληψη του Επίκουρου για τον κόσμο. Και η μορφή του κόσμου λέει ότι οι κόσμοι έχουν διαφορετικά σχήματα. Δηλαδή, άλλοι είναι σφαιρικοί, άλλοι οειδείς και άλλοι έχουν ένα διαφορετικό σχήμα. Φανταστείτε τους γαλαξίες, ελλειπτικοί, σπυροειδείς, ανώμαλοι, διάφορα σχήματα και διαφορετικές δομές παρατηρούμε στους κόσμους μέσα από τα τηλεσκόπια μας, από τότε που υπήρχε τηλεσκόπιο μέχρι τα σύγχρονα μέσα που παρατηρούμε σήμερα το σύμπαν. Έχει πολλές λεπτομέρειες και πολλές περιγραφές που πραγματικά είναι εντυπωσιακό να διαβάσει κάποιος Επίκουρο και πώς παρατηρεί και πώς περιγράφει, όχι πώς παρατηρεί, πώς περιγράφει τον κόσμο ένας άνθρωπος που δεν ήταν αστρονόμος. Με τη φιλοσοφική σκέψη και τον καθαρό νου περιγράφει τον κόσμο με έναν τρόπο που τον παραλληλίζουν πολύ εύκολα με τη σύγχρονη αστρονομία και τη σύγχρονη αστροφυσική. Και οι κόσμοι, λέει, είναι φθαρτοί και ότι μεταβάλλονται τα μέρη τους. Δεν είναι στατικοί, δεν είναι σταθεροί, υπάρχει αυτή η εξέλιξη. Γνωρίζουμε για την αστρική εξέλιξη, για τη μεταβολή των κόσμων που παρατηρούμε στον ουρανό. Και ξανάρχομαι στον Byron, γιατί λέει για τους αμέτρητους κόσμους που υπήρξαν και θα υπάρξουν. Έναν ανεμοστρόβιλο δυσβάσταχτων πραγμάτων, ήλιοι, φεγγάρια και γέες με τις θορυβώδεις σφαίρες τους, να τραγουδούν με κεραυνούς τριγύρω μου. Οπότε βλέπετε πώς η αστρονομία με τη ποίηση, με τη φιλοσοφία, με τη μουσική, με την τέχνη εμπλέκονται από ανθρώπους που ανήκουν σε όλες αυτές τις κατηγορίες και που έχουν τη σκέψη, την ευρεία σκέψη να μπορούν να συνδυάζουν πράγματα. Και για να ολοκληρώνω, στη σύγχρονη μουσική και ο Ιάννης Ξενάκης από τους σπουδαίους συνθέτες του 20ου αιώνα επηρεάζεται από την αρμονία των σφαιρών, από την ιδέα αυτή της θεώρησης του κόσμου. Ο Ανέστης Λογοθέτης, ένας Έλληνας σύγχρονος συνθέτης που δεν πολύ γνωρίζουμε, αυτά δεν είναι σχήματα ζωγραφικά, ούτε χορευτικές φιγούρες, αλλά είναι μια σύγχρονη παρτιτούρα γραμμένη από τον Λογοθέτη, στο έργο του Himmel Mechanics, η μηχανική του κόσμου. Οπότε αναφέρεται σε αυτή τη συμπαντική μουσική, τη συμπαντική αρμονία με το δικό του συνθετικό τρόπο. Οπότε έχουμε πολλούς συνθέτες οι οποίοι επηρεάζονται και εκφράζουν αυτή τη θεώρηση του κόσμου μέσα από τη μουσική τους μέχρι σήμερα. Οπότε χρησιμοποιούμε τον ήχο του διαστήματος και για την έρευνα και στην εκπαίδευση και στη δημόσια κατανόηση της αστρονομίας και στη διδασκαλία της αστρονομίας για ανθρώπους που έχουν προβλήματα όρασης. Είναι πολλές εφαρμογές που μπορούμε να εφαρμόσουμε έτσι, με αυτόν τον σύγχρονο τρόπο. Και το ζήτημα είναι γιατί τα κάνουμε όλα αυτά. Γιατί μελετάμε, και είναι ένα ερώτημα που είχαν θέσει και στον Επίκουρο, γιατί μελετάμε τον ουρανό, τα αστέρια, τις επιστήμες, την αστρονομία, γιατί γράφουμε βιβλία και διαβάζουμε βιβλία για τον ουρανό. Ποιος είναι ο στόχος? Ο καθένας έχει την απάντηση βέβαια για τον εαυτό του, αλλά η απάντηση που ο Επίκουρος δίνει είναι ότι δεν μπορεί κανείς να απαλλαγεί από τους φόβους για τα πιο σημαντικά πράγματα αν δεν γνωρίζει ποια είναι η φύση του σύμπαντος και δίνει βάσεις στους μύθους που λέγονται γι' αυτό. Συνεπώς, δεν μπορεί κανείς να απολαμβάνει ακέραιες τις ειδονές της ζωής χωρίς τη φυσική επιστήμη. Γι' αυτό μελετάμε τις επιστήμες, για να προσεγγίζουμε την ευδαιμονία που ο φιλόσοφος εδώ μας υποδεικνύει και να απαλλαγούμε από τους μύθους τις δυσιδαιμονίες, τους φόβους, την παραπληροφόρηση και την ψευδοεπιστήμη που δυστυχώς ανθεί στις μέρες μας και στη χώρα μας. Οπότε, με αφορμή τις 10.001 νύχτες του σύμπαντος, που ίσως δεν φτάνουν για να το μελετήσουμε και να το περιγράψουμε, έκανα αυτές τις σκέψεις και ευχαριστώ πολύ τον κύριο Ελμπάζ που έδωσε αυτή την αφορμή για την απόψινή κουβέντα που θα συνεχιστεί.
Otherwise, you will think that we are just not real scientists. Normally, we're not supposed to be. So, for me, it's a real pleasure to be here in Greece because I love Greece. I've been collaborating with some colleagues in Greece, and I am a fan also of the Greek salad. It doesn't work. And now, by an interesting coincidence, I didn't know what you were going to say. So it wasn't planned. I knew that you were going to speak, but I didn't know what you were going to say. And so you will see that by the end of my presentation, we'll reach a common point on something. But I will progressively reach that. I wish to start by mentioning the fact that last night, you are probably aware that there was this Artemis 2 rocket that was launched in space to go back on the moon. In fact, this time they will turn around the moon, and then another time there will be another rocket, Artemis 3, and then Artemis 4 to go on the moon. It's the last time we went on the moon was in 1974 with Apollo 17. And first, it is teaching us several things. The first thing is that it's very hard to go back to the moon even though we went there a long time ago. That shows that when you stop science for some time, it's very difficult to recover. You lose memory. That's one thing. Another thing is we can wonder, what did we learn by going to the moon? When people went on the moon, they brought back some rocks. And with those rocks, we were able to see things we couldn't see on Earth because the Earth was erased most of its memory because it was melted. And we saw that the Earth was, there was some, let's say, collisions of asteroids on the Earth for during probably 1 billion years, during the first billion year of lifetime of the Earth. And then 3.6 billion years ago, when that stopped, life appeared on Earth. So it's a very interesting indication that life, even though it seems to be a very complex process to have life emerging somewhere, it emerged on Earth quasi-instantaneously after Earth stopped being bombed, in some sense, by all these asteroids. I want to say something which is a bit interesting, an anecdote. It's like when Armstrong went on the moon, he was walking on the moon, and then Aldrin went on the moon, and then Collins couldn't go on the moon. He was orbiting around the moon, and journalists asked him, well, you went up to the moon, you stayed there and you didn't go. What did you think about? And he said, I was thinking about white mouses, like Mickey Mouse, white mouses. And they said, why? Why white mouses? And he said, because when they came back on Earth, they didn't go back to their family. They didn't go back to their government. They didn't go back to their friends. They were put in a room with white mouses. Because at the time, people thought that life was everywhere and that they were possibly bringing a lunar flu, a moon flu. That means that possibly there were some bacteria on the moon, there was some kind of life on the moon, and they would bring it back. So first you have to test on the white mouses if they survive, and then you let the astronauts come back to see the family and the government. So it's very interesting because today we are still wondering whether there is life in the universe, but we have a different perspective. We see that it's very complex, etc. I have some colleagues who think that there is only life on Earth, and some who think that there is life elsewhere. So we are really progressing very fast in trying to understand how life emerged in the universe, and we go step by step. And in some sense, what we are trying to do is to reconstruct a story in which we are actors in some sense. And Georges Lemaitre who is represented here when he was young, he wrote a paper where he took again the sentence "mundus est fabula" that was mentioned by René Descartes, which means the world is a tale, like a fairy tale, is a story. And he added that each generation strives to improve. And he's the one who found that there was a beginning in the universe. The idea of a beginning is not very clear. It's not necessarily an origin of the universe. It's a beginning. And he has his own interpretation of what it means. For him, it's the beginning of multiplicity. We can discuss that if we want. But the thing is that every generation is trying to improve this story. And that's the goal of astronomy today, is to trying to improve this story. And that's why I wrote this book as a bit like the stories of the old times, like the 1000 Nights, where you have each time a story ending with, but that is another story. Because every night we have been observing the universe and trying to better understand the universe. And what we have been finding in the universe can be summarized by something that Edgar Allan Poe wrote. It's a very little book that he wrote in 1845 called The 1002nd Tale of Scheherazade. So Scheherazade, you know the story, I guess, that there is this king of Persia who discovers that his wife went with another person. So he killed the wife and he decided never again. So the best way to avoid your wife to cheat on you is to kill her every morning. So he had a new wife every night and then he killed her every morning. And after some time, Scheherazade decided to try to save these women by offering herself to him. And each night she would tell him a story and then stop in the middle of the story and he would like to know the following. And she said, Anna, that's another story tomorrow. And that way she didn't die. That's, I think, the best way to tell stories. Now, Edgar Poe thought about what could have happened one night after the 1001 night, 1002nd night. Remember that what she told to the king of Persia was that there was a flying carpet with Aladdin, there were some Ali Baba and the 40 thieves, there were some giants, there were like crazy things, and he accepted all of that and he followed the stories. Then, the 1002nd night, she comes to him and she says, you know what? There is something even more amazing than the flying carpet and all those things. It's the fact that everyone, whether it's a kid or an adult, whether it's a dog or a cat, when he looks above, he can see the past 20 million years in the past. And then the king of Persia said, no, that's crazy. And he kills her. That was too much, but that's true. The only thing that was true when she talked to him was the thing he couldn't accept. And so Edgar Allan Poe explains in the notes at the end of the book that he was following very closely the developments of science and the fact that we could see the past by looking at the universe was very interesting to him. And now, during the last 10,001 nights, we have experienced a complete revolution of our understanding of the history of the universe. 10,001 nights bring us back to 1995. We are about 10,001 nights since the discovery of the first planet orbiting around a star like our sun, which was discovered by these guys. And it was really a surprise because, in fact, this planet is like Jupiter. Jupiter is a giant planet. And to make a giant planet, you need a lot of ice cubes because in space, there is a lot of ice. And if you are close to the star, the ice is evaporated, and you cannot have massive planets close to a star. That's why the Earth is small, Mercury is small, Neptune is small, and Jupiter and Saturn, they are big because they could get a lot of ice cubes which are further away than the limit between Mars and Jupiter. And there you can have ice cubes. So you cannot have a massive planet, a gaseous massive planet, close to the star because it would be exactly as if you were boiling water in your kitchen and then you find an ice cube on the boiling water. There is a low probability that happens. You can boil water 1,000 times, you will never have an ice cube. Now, these guys, they were observing a star, and they saw a giant planet very, very close to the star, closer than Mercury, which means an ice cube in boiling water. It's impossible. That's why the American colleague that was observing the same system didn't even look at it, because there was no way there would be an ice cube there. Now, that's one lesson for me, which is the fact that things that appear absurd to you may be part of the science of tomorrow. And the conspiracy theories are a way to tell you that we understand everything, and nothing is absurd in a conspiracy theory because they have an explanation for everything. So as long as someone tells you a story where nothing is absurd, that's absurd. And science has this ability to accept something which is absurd, and that's what happened, and they got the Nobel Prize, like you would catch a flu. Because they just did it without willing. I mean, it's just random. They were by chance. Sometimes you can get a flu, sometimes you can get a Nobel Prize. October 1995, this picture of the pillars of creation changed the world of astrophysics because it was on the first page of many newspapers and many books. Many astronomers themselves realized that the universe could be beautiful. And it was the moment when really the beauty of images of the universe came into the houses of everybody. It was used for advertising, for everything. And of course, this is connected to art because the colors are wrong, are fake. And of course, these pillars are not vertically oriented. There is no verticality in space. But the astronomers in NASA decided to call them pillars of creation. It's a bit religious, pointing towards the high altitude, and the colors are exactly the same colors that the ones that were used by painters painting the western side of the United States in the 19th century. There is a historian of art who realized that it was exactly the same kind of colors that they were using. In fact, they were working with artists. It's astronomers and artists making these images. It's not only astronomers. And it has made a revolution. And of course, it has also revolutionized our understanding of planet and star formation. I will say a few more words about it afterwards. And then in December 1995 came this picture, which is called the Hubble Deep Field, where in one image, you have dots of light which are coming from different times in the past, because the ones which are very far, their light took a long time to come to us, sometimes 10 billion years, and therefore, this is not a picture, this is a history book. This is a history book in one picture. And after analyzing this image, it was realized in 1996 that stars are formed in the universe in a way that has evolved with time. It has become more and more intense. The universe has become more and more, the fecundity of the universe has increased, reached a maximum at a moment called cosmic noon, and then started decreasing. And now the universe is getting old. When you get old, your cells die. In the universe, the cells of the universe, galaxies are dying, they are becoming passive, they don't form stars anymore. That's one of the big mysteries of the universe, and I will talk a bit about that. So, 10,001 nights ago, we had that as a start. It's just the start, and since then, everything has been accelerating. On July 11, 2022, Joe Biden realized the importance of these images and what it had in mind on people. And we were expecting the release of the images by the journalists on July 12 with some scientists. They were supposed to be press releases and everything. And then, so on the Tuesday, but on the Saturday or Sunday, Joe Biden said, no, I'm going to do it one day before you. I'm going to do it on July 11, and I'm going to present this book of the whole history of the universe made by the James Webb Space Telescope, the most powerful telescope ever launched in space. Now, there is a connection between that and the space conquest, like the Artemis program and the Apollo program. Here is the connection. Why do we call the telescope that made this image the James Webb Space Telescope? James Webb was not an astronomer. What is his contribution to science, to discoveries? It is equal to 0. It has done nothing. And he has the name of the best telescope ever made. It's not the Einstein telescope, it's not the Galileo telescope, it's the James Webb telescope. Now, why? Because in the just before, in early 60s, James Webb was the administrator of NASA. And you can hear a discussion between him and Kennedy. And Kennedy tells James Webb, okay, I'm going to spend billions of dollars to go on the moon. And I want to go on the moon before the Russians. And then James Webb says, Mr. President, the Russians, they have a bigger rocket. They have more expertise in going in space. It's going to be difficult. So if we want to go on the moon before the Russians, I need the best scientists. And if I tell them that we just want to go on the moon to be faster than the Russians, I don't want to get the best scientists. I have to tell them that we're going to do some science, like understand things. And then Kennedy says, okay, science, I understand, like curing the cancer, all those things, I understand. But that's not what I'm talking about. You will do science after. Now I just want to go there before the Russians. That's the only thing. And then they continue like that. A third person speaks and says, Mr. President, I think that Mr. Webb wants to say, and then Kennedy becomes very upset. He says, I understand what he wants to say. I'm just telling you I want to be there before the Russians. But they continue like that. And then he says to James Webb, okay, write what you want on a piece of paper. And then he wrote what he wanted. And then Kennedy leaves, and you hear a person telling James Webb, but you didn't tell him that you're already using part of the Apollo program money for science. And Webb says, well, he doesn't need to know. So the science we're doing here has nothing to do with the fact that human beings want to understand the universe. It's just the fact that big governments want to show that they are more powerful. And scientists, we take advantage of that and we do science, okay? But I'm not going to try to tell you that we're going on the moon to understand the moon. The reason why the Americans now want to go on the moon is because they want to go not before the Russians, but before the Chinese. And with that money, with some luck, maybe we can understand something. So that story started on 11 of July 2022, and then we made some puzzling discoveries. I'm going to talk about some of them and not all of them. At least the beauty of the universe was confirmed. This nebula here is one of the most beautiful pictures ever taken by a telescope. It's taken in the infrared, and you can see inside the dust where stars are formed. And in that nebula, stars are formed, planets are formed. And if you zoom in it, you can see again the pillars of creation that were observed by the Hubble Space Telescope. But this time by the James Webb, we can see through the dust. And we can even see this kind of red thing here. And this red thing here is a star which is being born with its planet around it. And we have another picture in the Ho-Fuki region where we see exactly the same thing here. And what you see, the black triangles here, is a disk of dust where planets are formed, like the Earth. And the red jets here is because matter is rotating and it's projecting matter all over. So what's happening here? It's a star is born like butterfly, which is born, it's in its cocoon. And when it's born, it destroys the cocoon and it flies away. The stars are born in a cocoon of dust. And then after they are born, they fly away. And this is a star that was born a bit earlier. And then they destroy the cocoon around them. And they make this kind of cave in space where the light destroys all of the dust. So here is the birth cloud where you can see stars and planets being born. And you can understand, for example, the fact that now there is about 10,000 stars and planets that are born every second in the observable universe. So there is a part of the universe we can observe. In that part of the universe we can observe, there is 10,000 new stars and planets every second. That means that at the end of this sentence, 50,000 new worlds were born. So each time you say something, whatever you say, think about the fact that during the time you said that something, 50,000 new worlds were born. I mean, not because of us, but it's what we know now. And now, in that region here, not only planets are born, but also molecules. And molecules participate to the emergence of complexity. And what we have seen is a completely new picture of a galaxy. So this is a classical picture of a galaxy, as you may have already seen, with stars turning in the galaxy. In fact, that thing, these arms like that, I will say a few more words after about that, but they come from the fact that stars are turning around the galaxy in ellipses, but they combine themselves and they make some waves where stars are born. Now, that is only the light from stars. We know that the first bricks that led to the emergence of life are complex molecules. The most complex molecules we know in space are like this one, with these benzenic cycles. It's 6 carbon atoms connected to each other. And these big molecules exist in space, and we can recognize them because when they vibrate or when they rotate, they make a specific light. Now, the James Webb has the ability to make an image of this galaxy where you don't see the light from the stars, you don't see the light from anything else than the molecules. By this image, you can see where the molecules are born and how it happens. And here is the image. This is a completely different picture that we had never seen before. It's the first time we see that. And it's actually quite beautiful. And it's exactly like the foam on the waves on the sea. And in the foam is where molecules are born. And when a star explodes, it destroys everything around. And this cavity here is due to an explosion of a star. So now we can even map where stars have been exploding and destroying after, when they die, destroying dust. So you could say, but when a star dies, it's destroying everything. No. What we realized is that if you look around the explosion, there is more molecules. In fact, each time one star dies, it gives birth to many stars, planets, and molecules. It's a bit like if you go to Hawaii, where you have a volcano, and you think it's the death of nature because you have the lava. And then you wait a little bit, and the vegetation comes, and it's like there is more flowers there than anywhere else. In the universe, when the star dies, it's the occasion for the birth of more molecules and more planets and stars. And we are witnessing it in the direct light of the molecules being born here. Now, what is making these molecules, this foam in the waves, is illustrated by this animation where you see how you have a wave like a wave on the sea. It's exactly that. The stars are not making the wave physically. They are all rotating in an ellipse, but it's what we call a density wave. That means the combination of all their movements, they make a region which is a bit more denser, and that's where you have the stars that are born in those waves. So, this is a galaxy that is, I like to say, dancing. That means it's rotating. And by dancing, it's making waves, and in these waves are born new stars. What is nice is that now, while I speak, we are moving at 800,000 kilometers an hour around the center of the Milky Way. We, meaning us, the Earth, the Sun, the solar system, is part of that. By our rotation around the Milky Way, we participate to the production of those waves. Those waves are the reason why new worlds are born in the Milky Way. So, by participating to the dance of the cosmos, we participate in some sense to the fecundity of the Milky Way and of the universe. Now, the reason, before I show you here an illustration of the bioluminescence in waves, where you can see a surfer that is surfing on a wave, and the white color that you see here is an illustration of the vitality of the ocean. People measure the vitality of the ocean by looking at that color. It's exactly the same kind of waves that are taking place when the galaxy is dancing. Now, it turns out that since 1996, as I told you, by looking at the history of the universe, we know that the universe is getting older. And there was this mystery. Why is the universe getting older? Why do we see cells in the universe which are dying, and cells in the universe are galaxies. And this is an illustration of that. This is a dead cell, and this is a living cell. This is a dead galaxy, and this is a living galaxy. What is the difference between the two? This one is not dancing. This one is dancing. In the universe, if you stop dancing, you die. Now, I'm going to say something. You might not trust me, but since I know that, I try to move more. And it's true. I am on my computer, I'm working, and I remember about the dead galaxies, and I think, no, I have to move. I'm getting fat, I have to move. The universe, for me, is a master teaching me something. And I cannot avoid noticing the similarity between the whirling dervish and a galaxy seen like that, whirling dervish that you see from above with the arms like that. And they say they are mimicking the dance of the cosmos. I'm not saying that they knew what kind of images we will get from the James Webb Space Telescope, and they know what is a density wave, and they know that these big molecules are hydrocarbon aromatic polycyclics, and that their emission is at 7.7 micron or 12.7 micron. I don't think they know that. But it's really similar. Now, I'm going to get closer to the connection to music. And to do that, I have to use an analogy with a movie that you might know, which is, The Good, the Bad, and the Ugly. But this time it's going to be the brain, the universe, and the scientists. The fonts, the police, the characters are a bit jumping away, but that's fine. So, what you see here, it looks a bit, the two look a bit the same, no? There, they are testing the activity of the brain. And there, those are optical cables that are put on holes, and each one of these little holes is at the position of a galaxy. So what we do, we take the light of the galaxy, and it goes through this thing, and then it goes in a machine that will read the message of the light, and you do the spectrum of the light to understand it. The same way that you do that for different parts of the brain. And you're going to see why I'm saying that. This is an actual zoom in the brain of a mouse. Turns out that our brain is a bit similar. Huh? So let's not be too pretentious. We have the same kind of thing. But this thing is a cell and connected with axons and dendrites with other cells. We all know very well these kind of pictures. Let me add one thing, is that the way we think is by excitation or inhibition of neurons. And neurobiologists recently found that, contrary to what they thought in the past, excitations are not very important. The most important is to have more or less inhibition. And you will see why it's important. That's now an illustration of the distribution of the cells of the universe, galaxies. This is made with a simulation, because with telescope images, we get close to that, but there are parts we don't see, we don't make enough light for us to see them. So I use this simulation, but it looks very similar. And the reason why I'm mentioning that, even though there is 25 orders of magnitude difference between the two, so it's very different in size, is because there was a paper published in 2020 by an astronomer and neurobiologist comparing galaxies in the universe and neurons in the brain. And they found they have the same structure at their scale. So of course, one is in billion light years or million light years, and the light year is 10,000 billion kilometers, and the brain is smaller. But if you accept that to look at the distribution of neurons with respect to each other versus galaxies with respect to each other, you find similarities. And they concluded that that's telling us that the way these connections are made may be they may follow similar physical laws. So this is another illustration where you have another image of the brain with various cells, and here various cells again. Now, I have a friend who is a neurobiologist, and he did the following. Exactly as you said, there are things that are difficult to see in a graphic, but when you hear it, it's easier. And he wanted to better understand the behavior of the brain. When someone has epilepsy, a very hard epilepsy, sometimes they have to do an operation and to surgery and to take part of the brain out with a spoon. So what they do, they open the brain with the box, they put electrodes, they close the box, and it's connected by Bluetooth. And you follow the brain activity during the day, the night, when the person is speaking, thinking, sleeping, dreaming. You have the whole history of the neurons, very well detailed. And then you see the part that is sick, and then they take it out and cure the person. Now, my friend wanted to better understand the behavior of the neurons. So he took the neurons and associated each one of them with a music instrument. The inhibition neurons are doing something like boom, 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 like that. The excitations are blah, 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 like that. So he used bass for the inhibition and then another instrument like xylophone or whatever for the excitation. And it's a beautiful music. And the first thing he noticed two important things, many, more than that, but there are two things I want to mention here. The first thing he noticed is that there is nearly no difference between when you dream and when you are awake. So he has this very nice sentence, which is that being awake is like a dream modulated by senses. Like the activity of your brain when you dream is for 95% the same than when you are awake. And a little bit of your neurons are connected to your senses. But most of what you see is not coming from your senses. Most of what you see is coming from internal loops in your brain. So, a conclusion of that is the following. It might be a bit disturbing. So if you want to think like you were thinking before, don't listen to what I'm going to say now. Now, since some time, I've been speaking to you, and you've been listening to me, and the person you see in front of you is an image that you have and that comes from your own culture, your own history, and what you've been hearing from me is completely different depending on the person who is here in this room. Because depending on your knowledge in science, depending on the way you interpret what I'm saying, etc., some people will say, oh, I like astronomers. Some others will say, those astronomers, they never understood anything about psychology or religion, whatever. Each one of you has heard a different story from me since I was speaking. And even though I've been using the same words, I know that after my speech, what you will remember has nothing to do with what I think I told you. I know. And I know that the image you have is coming from your own story. And it's proven. It's completely proven. And so that means that we have to take that into account when we understand things. And even when we look at science, we are influenced by our theories that are explaining many things, but preventing us to see things which do not match the theory. And if it doesn't match the theory, we might not even see it. There are experiences that show that we don't see things that don't match what we expect. And that's a challenge for scientists. So that's one thing. The second thing is even more interesting. There is another way to register the activity of your brain is that when you sleep, your brain has some waves and it encodes everything you've seen during the day, and it does that by waves in your brain. And you have waves of various frequencies. He registered his brain during the deep sleep. He translated that in music. Then he was in the plane, and he listened to his brain sleeping, and he fell asleep. And he thought, that's crazy, I have to do it again. He did it again. And then he created a startup to help people fall asleep by listening to their brain when they are asleep. Now, I am doing that every night. I cannot sleep at night because I don't know, I'm stressed, I'm whatever. And my wife, when she goes to bed, horizontality for her means sleep. She goes horizontal, poof, she sleeps. Me, I goes horizontal, I don't see the connection. I'm waiting. I don't know what's going to happen. I'm waiting, nothing happens. And then I listen to my brain, and I fall asleep. So that thing is coming from the registration of the activity of the brain. Now, what we found is that we recently found that in galaxies, we also thought that what was important was excitation. We call them starbursts. That means that when you excite star formation. And then we recently found that no, what counts is inhibition. Excitation are very rare in the universe. And we found laws that are in the universe of, that's the connection, that mimic those of living bodies. So this is the only law that is telling you something about your life expectancy as an animal, which is that more massive animals live longer than low mass animals. An elephant lives longer than a squirrel. Of course, an elephant is not a squirrel, but they all have typically 1 billion heart rate. A human being has, because of medicine and everything, we can get 2 billion. So it's like we have the same partition of music, but if you're a squirrel, the tempo will be faster. And if you're an elephant, tempo will be slower, but you play the same music. You have 1 billion notes, sometimes 1 billion plus one. And that's for the animals. Now, for the galaxies, we found a similar law. And that was very puzzling because animals, they are very different. A squirrel is not an elephant, yet they fall on the same law. Galaxies, they have very different shape. There are no galaxies that look the same. They are all very different. Yet their rate of star formation, which is equivalent to the heart rate, is universal and depends on the mass. And that was a very puzzling discovery that we found, which is telling us that there is a self-regulation mechanism in galaxies, which is a bit like in living bodies. That means if the galaxy starts to form stars too much, if it has a heartbeat too fast, there will be many explosions of stars making those cavities, and that will decrease the density of the gas and reduce the star formation, and therefore it will become peaceful again. So the galaxies are like self-regulated, like a living body, and they follow laws like living bodies. Now, the last thing I want to say is that this is the reason why galaxies dance is exactly because of this interconnection between galaxies. That means the matter falls into the galaxy, makes it turn, and that's because galaxies receive this matter that they are dancing and turning. So this whole story is telling us that what we thought were islands in an empty space where everything was more or less unchangeable and eternal is in fact all interconnected, changing all the time. As you said, the only thing that is eternal is the fact that nothing is eternal. The only thing, everything changes all the time. Stars are exploding, galaxies are changing shapes, are transforming, planets are being formed, and the laws of the cells of the universe mimic a little bit the laws of the cells of living bodies. This interconnection, this dance of the cosmos is at the core of the book that you can read. Thank you.
Reading your books and hearing your presentation, it creates a feeling of magic. It's like reading a fairy tale. And we really appreciate that and thank you for that. I teach physics and somehow I communicate science as you do. If there was one piece of advice that you could give teachers about enriching with magic their lessons, what would that be?
What comes to my mind is the following, is that when we teach, we want to give. I met this guy, Robinson. He was the head of the James Webb Space Telescope. He comes from a poor district in the US. He's black. Black people are, very few people are black in astronomy. So he was black in a poor place, etc. And he used sport to become, to to be able to access knowledge and education through sport. And he became the responsible for the James Webb Space Telescope. So I had lunch with him, and he said, you know what's my secret? Is when I go to someone and I want to tell him something, I don't go to someone with who I am. I go to someone to listen who he is, where he is, from where he is listening to me. Because if I don't know where he is, he will never hear what I'm saying. That's the difficulty, is to give something to someone. The best way for me is by being in a situation where you receive. Now, you're teaching, so you cannot just be sitting and receiving. But I've been trying that technique, like, for example, even when I do my show, I am the only one. I do a show in Paris, in the theater, I speak for 1 hour, and I did this trick. I try, because I'm not an actor, so I cannot play. I'm trying my best, but... So once I played by thinking of the things I want to say, and I try everything I want to say, and I know that I have to speak fast or slow, and all the tricks you can think about to have people get the thing. And I had some reactions. But then I thought, okay, it doesn't work like that. I'm going to now be listening to them as if at any moment of the show, they could tell me something. And so I'm speaking, but listening. And then people started laughing, started having reactions to what I was saying. And I thought, oh, how did I say that? So I have to remember how to say that because they laughed now. And I should say, like that, or like that. What should I do? Or should I do like that, or whatever? And in fact, it has nothing to do with what you do, what you say, whatever. They know that you care about them. And I don't know, it's magic. They know you care about them. Now, if you don't care about them and you pretend to care about them, it doesn't work. If you care about them and you don't say anything that shows you care about them, they know. My PhD student, for example, I'm very harsh with him. And I'm wondering how he's going to resist, etc. But I'm very proud of my student because he's doing really great. And I don't want him to see because otherwise he will think, okay, I got, this one is in my pocket, etc. So I'm hiding the fact that I'm proud and that I'm listening to him, etc. And I realize that he knows. He knows it. And I tell him something harsh and he smiles. So that's the thing. I think it's in the invisible. There are people who have there are probably some real techniques that people will know. But for me, it's the how we are that changes the thing.
Άλλη ερώτηση?
Θα ήθελα λίγα λόγια για τη σκοτεινή ύλη και αν μπορούμε να γυρίσουμε στο παρελθόν.
So there are two questions. One is a few words about dark matter, and the other one, can we return or can we see the past? Dark matter has been invented to explain why galaxies are dancing so fast. The sun is moving at 220 kilometers an hour, kilometers per second, sorry. So 800,000 kilometers per hour around the Milky Way. At this speed, it should have escaped the galaxy since a long time. We are moving fast enough to escape the gravity of the stars of our galaxy. And yet, we continue to turn in it. So, we have invented an extra gravitational effect coming from some matter that doesn't produce light. The problem is that we don't see it. And the fact that we don't see it starts to be a problem. Because we have invented dark matter, we don't see it. Now, the universe has an expansion which is accelerating due to an energy we don't see. Now, when we measure the rate at which the universe expands in the past or today, it is not in agreement. It's called the Hubble tension. And then on March 19, 2025, there was an announcement by some scientists that the expansion of the universe doesn't follow anymore the law of the general relativity of Einstein. And point after the other, one after the other, we start to think that maybe we are missing a point. So maybe dark matter exists and we will see it tomorrow, or maybe it's one of the various reasons why we should find a new theory. So today we are facing that. Actually, the new book I'm writing is about these connections that I call the day after Einstein in some sense. And regarding the past, we are like police, the police who is trying to understand who is the killer. You have a crime in a room. Problem for the police is that they have only a few clues. They cannot see the crime happening. When we see dead galaxies, we can see the moment when they were still alive, because we can see galaxies that were further away from us, and we can see them because the time it took for the light to come to us is long. Now, we make some hypotheses to say that they are the ancestors of this one. We have some ways to find that. And that way, we see the past. And what's puzzling is when we see the past, it's exactly as if we were going deep into the ocean. And the first time we went deep into the ocean, we found new species of animals that live without the light of the sun. And they live with chemical reactions, and it changed our perspective on how life can exist. Now, by looking in the past, we found new things in the universe that we don't understand. They look small, they are red, we call them little red dots. We have written 816 papers to say that we don't know what they are. It means that we really don't know.
Galileo Galilei said once that the book of the universe is written in the language of maths. That universe should be described by calculating algebra, geometry, because you previously said about the galaxy. That is spiral. Okay. That should be math by the aspect of the golden rating of Fibonacci. So do you still believe that universe is nothing more than math, or something beyond it? Okay.
So you're asking, is the universe more than math? That's a big debate. In France, we had a debate between a neurobiologist and a mathematician. The mathematician was saying that math exists by themselves, and we are rediscovering math that exists. And the neurobiologist said, no, I know how your brain works. You're inventing everything. I can tell you because I'm in control. I know the brain. And they never agreed. Are we inventing these laws? Are we inventing the math? Are we discovering things that are existent? Is the universe, can we reduce the universe to math? Let's say that here it's a personal opinion. You might be able to reduce the universal laws of the universe to math. But science has been very successful in extracting by abstraction universal laws, which we can express by mathematics. Now it is facing a new challenge, is to explain the variety of shapes that you see in the universe, the complexity, the singularity. And that's connected to what we call contingency. It's connected to the history, to the encounters that things have together. And we are more and more becoming historians that describe the universe as a history with different phases, etc., because it cannot be reduced simply to math. Now, up to which level? So the challenge is still on. Now we are entering into a new era called the exascale era. So what is this era? It's the most powerful computer that is starting to work now, has the ability to do 10 to the 18 operations per second. So it's 1 billion of a billion operations per second. So with these supercomputers, people think that they're going to be able to make virtual twin universes that are looking a bit more like our universe. But some others say, no, we are missing something more than just using our universal laws and putting that in a computer. For the moment, what I like is the idea that we don't know. The fact that we don't know is very important for me because that's the reason why we continue to progress. So I don't know the answer to your question, and I hope we won't know for a long time.
Γνωρίζουμε πόσο σημαντική, βιώνουμε μάλλον όλοι οι άνθρωποι πάνω στη γη, πόσο σημαντική είναι η παρουσία της σελήνης στη ζωή μας. Γνωρίζουμε επίσης ότι η σελήνη απομακρύνεται κάθε χρόνο από τη γη 3 εκατοστά. Πώς θα ήταν άραγε αυτή η γη χωρίς τη σελήνη, απομακρυσμένη χιλιάδες χιλιόμετρα από τη γη? Πώς θα ήταν η ζωή πάνω, πώς θα είναι η ζωή?
So the question is about the fact that the moon is moving away from us and how will be the life on Earth after the moon goes away. It's true that the moon has a very important role because it's stabilizing the Earth on its orbit, and it's the reason why we have nice seasons and everything. But human beings are very inventive. They have found a way to create chaos before the moon leaves. So let's hope we survive because we see the moon further away.
As we do nowadays, because of the different distance.
Yeah, will we be able to observe eclipses in the future because of that change? It's true. So that's a very important question, and that's one that has been used by religion a lot. The moon and the sun have the exact same apparent size, which is half your thumb. So if you put half your thumb like that with your arm like that, you close your eye, the moon will be half of your thumb. It looks small, but you will see it's always like that. Now you will tell me, but this guy is taller than me. Yes, but he has a bigger thumb. So it's going to be the same size anyway. And the kid, closer, smaller sun, it's always the same thing. It's 30 arc minutes. When people speak about the big moon, it's fantastic, they speak in the news, etc. It's a complete fake news because in fact, when it's slightly bigger, but in a way that you won't see with your eyes. It's always half your thumb. Now, it's a weird coincidence that the moon and the sun have the same apparent size. Some people have been saying in religion that it's the proof, it's a sign of God. Some scientists have been trying to understand why they have the same size, if there is a physical origin. There has been papers published on that, and some of them saying that if the moon was a bit bigger, more massive, it would move faster, and therefore it would be a bit further away. And they tried to explain that it's a natural result of the orbiting of satellites and everything. But then, if you were on Jupiter, the moons of Jupiter don't make a perfect eclipse with the sun if you were living on Jupiter. So for the moment, it's just a weird coincidence. And indeed, in some future, we won't have it anymore. So yeah, it's a strange thing. Yeah.
Eclipse hunters in this room, and they're worried about this. Yes, there are some colleagues. Okay.
Θέλετε να μιλήσετε εκεί πίσω που δεν... Σας ευχαριστούμε πάρα πολύ. Να είστε καλά. Όποιος θέλει να υπογράψει ο Νταβίντ το βιβλίο του είναι διαθέσιμο.